Bit.
Yes, ma'am.
Bitwise or
Started.
We were starting with bitwise operator.
Okay, bitwise operator. Okay.
Ma'am, can you explain again that part, that bitwise and when we are taking the x value as 9 int, x value as 9 and y value as 8.
I will explain it again. I will explain it again. Okay. I am just sharing my screen with you.
sure, ma'am.
Then I will again start it with the bitwise operator. Is the screen is visible to all of you?
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Okay. So before bitwise operator, uh, let's have a discussion on the um, number system. Okay, because most of the computation we are going to do using this number system. Okay, just make it a clear idea on the number system, then we are going to have a discussion on bitwise operator. Okay, so in number system, as we all know, we have decimal numbers, we have binary numbers, then we have octal numbers, and we have hexadecimal numbers. Hexadecimal numbers. So binary numbers or decimal numbers, it is a set of numbers that are formed from the numbers from 0 to 9. Okay. So this is known as our decimal number. Okay, deci means what? Deci simply implies 10. So we are having the 10 set of numbers from which we are forming the decimal numbers. Binary means by two values are there, that is they are 0 and 1. Similarly, octal represents 8. So we are having 8 sets of number. So using this 8 sets of number, we are forming the octal number. All of you clear? Okay, and this part is not there in slide. So if you want, you can make it a note. Similarly, hexadecimal number, we are having the numbers from the set 9, 10, 11, 12, 13, 14, 15. Okay, so from us we have decimal numbers from 0 to 9. It is there 0 to 9, and 10, 11, 12, it is represented as A, B, C, D, E and F. Are you clear?
Ma'am, 8 is missing in decimal.
Oh, I have skipped the 8 part. Okay, and just when 8 and 9. Is it correct? Yes. Now, all of you clear with the decimal, binary, hexa? Hexa, it implies your the 16 number, and deci, hexadecimal number. So my number system that we are going to use in our computers are basically forms of the binary decimal. We are using it. We are either converting it to binary, or we are converting it to octal or hexadecimal. In detail also, you are going to study in your higher semesters the number system. I am not going to discuss it with you in details, but we should have a brief introduction on it, because you are going to have a number of problems based on this number system. Okay, all of you clear with this point up to this much?
Yes, ma'am.
Yes, ma'am.
Yes.
Okay. So make your fundamentals strong, because here we are only discussing with the fundamental concept, and the logical part again we are also going to discuss with the fundamental concept. So don't need to panic. If you don't have computers also, no problem. we are going to discuss in detail. Okay. So anytime you have any doubt, you can ask me. Okay. Now the next thing we are going to do, we are going to convert binary sorry, it will be decimal to binary conversion. So whenever we are going to convert a decimal number to binary, so what are the things we are going to do? We are repetitively divide the number repeatedly by 2 until 1 or 0. Okay.
Yes, ma'am.
Are you clear? So now we are going with a number. I am taking here a number is 18. Okay. So 18, what I am going to do? I am going to divide it by 2. Okay. So if I am going to divide it by 2, 2 nines are
18.
2 nines are 18. The remainder is
0.
0.
0. Here I have written the remainder. All of you be careful with it. Where I am writing the remainder again. 2 twos are 2 fours are
8.
2 fours are 8. What is the remainder?
1.
1. Here I have written 1. Again 2 twos are
2. 2. 2. 0.
4. What is the remainder?
0.
0. Again 2 ones are
2.
2. What will be the remainder?
0.
0. So if we are going to write in this way, now here I have just organized it. So how we are going to write it? We are going to write it in the reverse manner. So what is the first here, down to up? We are going to write in the fashion down to up. So what is the first number here?
1.
1. So here 1 will be written. What is the next number?
0.
0. Then what is the next number?
0.
0. Then what is the next number?
1.
1. Then what is the next number?
0.
0. So we are writing the number in this order. So it is what? 1 0 0 1 0. This is my binary representation of a number. All of you clear with this point?
Yes, ma'am.
Yes, ma'am.
Are you clear, all of you?
Yes, ma'am.
Okay, if you are clear, I am giving you one question. Just do it. Not. 49. Find out if 49 it is a decimal number. Find out the binary representation of decimal. Just do it.
Ma'am, 1 4 times 0.
1
11001.
Ma'am,
Ma'am,
11001.
Ma'am, double 10001.
1100
101.
01. All of you clear with this one, or anyone having any doubt, kindly ask me. Okay, otherwise you will finding it difficult while we are going to do the bitwise operator. All of you clear with this point? Those who have doubt, raise your hand. Those who have doubt, raise your hand. Okay. Srinath, look. So how we are doing it? We are going to divide repetitively 49 by 2. Okay. Are you getting? Srinath.
Yes, ma'am. Yes.
So, if I am going to divide 49 by 2, so what will be the value here? 2 2s are 4, 2 4s are 8. What is the remainder?
1.
1. Here I have written 1. Now again I will divide 24 with 2. So here what will be the value?
12.
12. What will be the remainder?
0.
0. Again divided by 2. Then what is the value here?
6.
6. What is the remainder?
0.
0. Again divided by 2. What is the value here?
3.
3. What will be the remainder?
0.
0. Again divided by 2. What is the value here?
Ma'am,
2
2. 1, 1, 1.
or 1?
1, ma'am. 1.
1. What is the remainder?
1.
1. You got the remainder 1. So how you are going to write from down to
Up. Okay, ma'am.
up? So what will be the value?
1, 1, 0, 0, 0, 1.
1 1 0 0 0 1. Are you clear now?
Yes, ma'am. Yes, ma'am.
And remember one thing, this bit is known as your LSB and this bit is known as your MSB. Okay, it is your least significant bit and this one is your most significant bit. All of you clear with these 2 bit positions?
Yes, ma'am.
Bit at the left is known as your MSB, most significant bit, and bit at the right is known as your least significant bit. Okay, because we are going to use MSB in the next topic. All of you clear with this point? Are you clear? Okay, next one is how we are going to convert the binary number to decimal. Here I am erasing this part. So we got here 1 1 0 1. So now the next thing is, in order to convert binary to decimal, we need to put the numbers. So here what is the value? 0, 1, 2, 3, 4, 5. Okay, I have just provided the index numbers here. Srinath, are you clear? Srinath. So here I have put it the numbers. So once I put the number, I need to compute it. So compute कैसे करोगे? How you are going to do the computation part? In order to do it, we are going to multiply this number with 2 to the power index value. Okay. So here, what is the number?
1.
1. So 1 will be multiplied with the index value of 1. What is the index value of 1? 2 to the power 0. Plus, यहाँ पर कितना आएगा?
0 into 2 to the power 1.
1. Then plus 0 into
That's 0 to the power 2.
plus 0 into
2 to the power cube.
2 to the power cube. Okay. Then 1 into 2 to the power
4.
2 to the power 4. Again plus 1 into 2 to the power
5.
5. So here, so which values are 0 now? यहाँ पर कितना आएगा आंसर?
0 0 0
0 0 0. Now what will be the answer here?
1
1.
1 plus
16.
Now what will be the answer here?
16 plus
What is the
32.
answer here?
16.
16 32
16. Again plus. What will be the answer here?
42
32. So what is the total answer?
49.
49.
You got the answer?
Yes, ma'am.
Yes, ma'am.
Okay. So I am giving you another question. Just convert. This one is my binary number. Find out the decimal value. Do it. Do this one. Sanskar, what you have done?
Ma'am, 93.
No, ma'am, nothing doubt.
93.
93.
Yeah, the answer will be 93. So here what is the value? 0, 1, 2, 3, 4, 5, 6. So we need to compute here 2 to the power 6 for this one, 2 to the power 4 for this one, plus 2 to the power 3 for this one, 2 to the power 2 for this one and 2 to the power 0. तो ये कितना हो गया? 1 plus 4 plus 8 plus 16 and 2 to the power 6 will be
64.
64.
4. So when we are going to add this number, what is the answer?
93.
93. All of you clear how we are going to convert the binary number to decimal?
Yes, ma'am.
Okay. So next we are just going for one octal number. Then we are going to start our bitwise operator. Now. Next one is your decimal to octal conversion. So how we are going to convert a decimal number to octal one? Now let my number is 53. If 53 is my decimal number, I need to convert it to the octal. Octal means base 8. So what here I am going to do? Again same process repetitively. With whom I am going to divide it as it is octal number?
8.
8. बताओ. Yeah, what will be the quotient?
6.
8 6 are?
48.
Yes, 8 6 are?
48. 5 remainder.
Remainder will be 5. Can I divide it further?
No, ma'am.
No,
How
ma'am.
divide होगा?
No, ma'am.
नहीं होगा. So we are going to write it in the reverse manner. So here again we will go with another step. 48, 48. Okay. So we are not going to divide it again. So here we are going to write it. What is the value here?
65.
65. Now convert 65 to decimal. So here what is the value? 0, 1. So 5 into 8 to the power
Plus 6 into
0 plus 6 into 8 to the power 1. So 5 plus
48.
48. What is the answer?
53.
Are you
53.
clear? All of you, are you clear with this point?
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
So next we are moving to our bitwise operator, because bitwise operator is all based on this binary numbers. Okay. So next we are going to have our bitwise operator. So you are going to get output based questions from bitwise operator. So be careful. So bitwise operator. So first we are going to, again we are having bitwise AND operation. So anyone from you have the doubt on bitwise AND? X and Y. So this is my truth table. So if both the values will be 0, here the output will be 0. If either 1 is also 1, then also my output will be 0. If we will get a true value if both the inputs are true. So it is my bitwise AND operation. So if I am going to rate it, and remember, bitwise operator operations are performed at bit level. Operations are performed on bit level. So here public static void main string args. So here I am writing int x is equals to 9, int y is equals to 8. Then instead of system.out.println, here I am writing simply println x and y equals to x and y and operation. So what is the binary of 9?
1001.
So those who can't find it, you can go with the way I am doing. So binary of 9 is 1001. Binary of 8 is
1000. 1000.
100. So we are going to perform the AND operation. A and B, what will be the value here?
0.
1 0 is 0. 0 0 will be
001.
again 0 0 is 0. 1 1 is 1. So here 0 1 2 3. So which value is we are going to find? 2 to the power
3. 8.
So here the output will be x and y is equals to
8.
8. All of you clear with this point?
Yes, ma'am.
Ma'am, repeat.
Look here, 9, it is here we are going to find out the binary 9. So what is the value of binary 9?
1001.
1001. Okay? Are you clear?
Yes, ma'am.
Then we are going to find out the value of y. Y का value कितना है? What is the value of y here?
8.
8. What is the binary 8?
1000.
2 4s are 8, 0. Again 2 2s are 4, 0. 2 1s are 2, remainder is 0. So what is the value? 1000. Is it clear?
Yes, ma'am.
Then perform the AND operation. AND perform करो, यहाँ पर truth table है. According to this truth table, you are going to perform the AND operation. So 10 will be 10 कितना होगा?
100.
0. Similarly, 00 is 0, 00 is 0, 11
1.
1. So the answer here is 1000. So find out the decimal of it. Decimal कितना आएगा? 2 to the power
3.
3. So what will be the answer?
8.
8. Are you clear?
8.
Yes, ma'am. Yes, ma'am.
Okay. So next operation we are going to perform is bitwise.
Ma'am, I have a doubt.
Yes, ask me.
Ma'am, if the ma'am here binary digits are equal, means number of digits are equal. If digits are unequal, then how we will perform?
No,
Let's
here
say
always the digits. Okay. So now let here instead of 8, here let I have taken what? 5. So what is the 5 value?
101.
101. Okay. How you are going to store it?
0.
Nee, how? What is the data type of it?
Integer.
Integer. Integer is how many bits?
4 bytes.
4 bytes. Okay, 4 bytes or 32 bit. So it will be internally stored in this manner. I am just showing you how it is being stored internally. Now, are you clear?
Yes, ma'am.
1, 2, 3, 4, 5, 6, 7, 8. 8 bits are there. This is 1 byte.
Yes, ma'am.
Again, this one is 1 byte. Again, this one is 1 byte. And this one is 1 byte. So, how many bits are there?
32 bits. 32.
32 bits. So, it will internally stored in which how in 32-bit format. All of you clear?
Yes, ma'am.
Yes, ma'am.
This is the value of 9 and this is 5. This is 9. All of you clear how it is being stored internally?
Yes, ma'am. Yes,
Okay.
ma'am.
Should I move to next one or you have any doubt?
Ma'am, I have a doubt.
Yes, ask me.
Ma'am, how can we convert floating point decimals into binary format?
Floating point decimals into
Binary
binary.
format.
Look,
Yes, ma'am.
in floating point, we have either 16-bit, 16 digit, sorry, 32-bit precision or how many bit precision?
64.
64. Okay, so whatever the number here is 5.4. Okay, we are going to represent this 5 in the form of binary. Again, we are going to find the 4 value in binary. Then we are going to do the conversion. I will explain it. I will explain this one. Okay.
Okay,
First,
ma'am.
we will cover with the integer value. Then we are going to do the this floating point operation. And one thing remember, bitwise operators, these are performed on the integers. We are going to perform the bitwise operation on integer. It can be byte, short, then int. Okay, so we are performing it on the integers, not on floating point numbers. Are you clear?
Yes, ma'am.
So this point is important. We are going to perform these bitwise operations on integers, not on the floating point numbers. So I will move to the next part, to the which one? And the operation, and I am coming back to this floating point number, how it is represented internally. X, this one is Y, this one is X, Y. So 0, 0 will be, for our operation, the 0, 0 will be 0, 0, 1 will be 1,
1,
1, 0 will be 1,
1,
1, 1 is
1.
1. Okay, if I am going to write int x is equals to 9, int y is equals to 8, println x or y, we are equal to within the inverted quote plus x or y. So here what is y value? 1001, and here I have not done completed, and your 8 value is 1000. So what will be the value here? 10,
1001.
1, 1,
1001. So here what you are going to get the output as?
9.
9. 9.
Okay, this one is your which operation? Binary or operation. Next one is your binary XOR operation. Mark it, most important, binary XOR operation. So in binary XOR, what we are basically going to do, and this binary XOR operation we are also using for our security purpose. So in most of the things we are using this XOR operation, bitwise. So in binary XOR operation, check it. If both the values are false or both the values are true, the answer will always be false. Okay. If either one is true, the answer will be true. All of you remember this point?
Yes, ma'am.
Binary XOR, note it down. If both the values are false or both the values are true, the answer will be 0. If either one is true, the answer output will be true. So now here what is the value? We are going to perform which operation?
Ma'am,
XOR
can you
operation.
repeat again?
Yes?
Ma'am, can you repeat again the condition? Like if both.
If both the values are, both inputs are true or false, the output is false. Otherwise, true. Okay?
Yes, ma'am.
For binary XOR. Okay? So here, if I am going to perform this XOR operation, XOR means ये key है. You need to press shift along with the 6 key. You will get this caret symbol. So if I am going to perform the binary XOR operation, I have written here 9. 1, 2, 3, 4. 1, 0, 0, 1. Then 4, 1, 0, 0, 0. So here, if I am going to perform the XOR operation, so what will be the output here? 0, 1 will be?
1.
0, 0 is?
0.
0,
1, 1 is?
0.
0,
0. And the rest bits are 0. So here, what will be the output?
1.
1.
ये 1 होगा, ये कितना है? 0 है. So 2 to the power 0 is?
1,
Oh, sorry, I'm wrong.
1. So here the answer will be?
1.
All of you clear up to this point?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Someone is having any doubt? Okay, no. So here I am clearing the screen. Next, bitwise not. Bitwise not. And logical not का symbol क्या है? This one. Okay, the symbol for logical not is this one. Whereas the symbol for bitwise not operation is this one. Remember this one. This is logical not. Okay, and this one is bitwise not. So here what you need to this key it is available shift plus tab, you will find this key. All of you clear? Bitwise not operation.
Yes, ma'am.
So logical not, it will perform the comparison. ये compare करेगा, but it will invert the bit position, invert bits. Okay. So here,
Yes, ma'am.
if we are having x, then we will again come back to the logical operations and the bitwise operation comparison. We are having x. यहाँ पर क्या हो गया? We are going to do the complement of x. If it is a 0, then
1.
1.
1. And if it is a 1, then
0.
0.
0. Now you are going to tell me the output. Public static what is the output? Just a minute, I will do a slight modification. Here instead of int, I will take here as byte. So if I am going to use a byte, in how many bits this value will be represented?
2 bits.
Bits.
सोच के बताओ, it is byte, so how many byte?
8 bit.
So it will be represented in
8 bits.
8 bits. So this is my value. So 5 is 101. So it will be represented in this form. So what will be the answer here?
Three.
Yes?
Ma'am, 1 1.
I'm two, ma'am.
2.
2.
2.
And 2. 2.
Yes, ma'am.
All of you got the answer 2.
Yes,
No,
ma'am.
ma'am. Three. Three.
Still in 3. Okay. How you are getting 3? Here, 1 is converted to
Zero.
0 is converted to
One.
1.
1. This 1 is converted to
Zero.
0.
0. And these are all converted to
Oh, shit.
1.
Is it correct? All of you getting this answer?
Yes, ma'am.
Yes, ma'am. Ma'am, 350.
350. Now, now I will open the Eclipse. Here what I have written? 5. Is it? You are
Yes,
saying
ma'am.
350. What is the answer?
-6.
This answer?
253, ma'am.
Yes?
And because it is out of range, so it has again gone through the cycle.
Ma'am, because our
Negative
MSB is
cycle.
1, so that's why.
Oh, it is out of range. Now you are just coming to the point. Now we have discussed this part in the lab. Okay, so we will do a detailed discussion here. So how it is being physically happens. So here my number is this one. Just pay attention here. So, and if I'm going to convert it, so here I'm getting 0, 1, 0, 1, 1, 1, 1, 1. All of you got this answer?
Yes, ma'am.
Okay. Now this is, I told you that this one is my
Lowest significant bit.
least significant bit, and this one is my
Most significant.
Most significant.
MSB, most significant bit. So all of you remember one point. MSB represents the polarity, or we can say it sign bit. Are you clear? Are you clear?
Yes, ma'am.
Yes, ma'am.
Okay, MSB represents the polarity or the sign bit. If 0 is there in MSB, then it is a positive number. Okay? All of you clear?
Yes, ma'am.
If 1 is there in MSB, then it is a
Negative.
negative number. Clear?
Yes, ma'am.
Next point, important point. Negative numbers are stored in two's complement method. How the negative number will get stored in the system?
Two's complement.
Note down this point. All of you note down this point. Negative numbers are stored in two's complement method. Okay, and these two are also important. Note. If there is a 0, then in the MSB, then it is a positive number. If 1, then it is a negative number. Have you noted it down?
Yes, ma'am.
Yes, ma'am.
All of you, Srinath. Srinath, are you there? Deep?
Yes, ma'am. I'm here.
Ma'am, what is the two's complement method?
I will come to that point. Have you noted it down? I will clear the screen now.
Yes, ma'am.
Okay. I am just erasing this part. In this last point, have you noted it down?
Yes, ma'am.
Look, everything is not there in the slide or the notes I have shared with you. So here, this is my, sorry. This is my MSB, most significant bit. Now it is a negative number. So how we are going to store it using 2's complement method. So write down what is 2's complement method, how we are going to find out 2's complement method. Rule. First rule of 2's complement method, convert or flip 0 to 1 and 1 to 0. हो गया? This is my first method. Second point. What we are going to do? Add binary 1 to the result of
Yes,
step
ma'am.
1.
Okay.
Got it?
Yes, ma'am.
So first convert or flip zeros to 1 and 1 to 0. Add binary 1 to the result of step 1. Okay. So here what is my number? 1, 1, 1. How many ones are there? 1, 2, 3, 4, 5. 6,
6, 5.
sorry. 1, 2, 3, 4, 5 ones are there. 4, 5, then 0, 1, 0. This is my number now. Okay. After making the complement operation, we have flipped our zeros to 1 and 1 to 0. We got this answer.
Yes, ma'am.
Yes, ma'am.
Okay, now it is a negative number. Just put a square mark on the MSB bit. Okay, now perform the step 1 of 2's complement method. So convert or flip 0 to 1 and 1 to 0. So here 1, this will be 0, 1, 0, 0, 0, 0. Don't change the sign bit now. Keep it is as it is. Okay, don't change the sign bit. Got it?
Ma'am.
Okay.
Yes, ma'am.
Okay, ma'am.
Okay, now next step, what you are going to do? Add
Binary 1.
binary 1 to result. So now this is my binary 1. So binary addition का rule लिख लो. When we are adding binary 0 with 0, the result will be
0.
0. When we are adding binary 0 with 1, the result will be
1.
1. 1 plus 0, the result will be
1.
1. 1 plus 1, the result will be
1.
0. Carry 1.
no carry 1. 0 carry 1. Okay.
Yes, ma'am.
So now here, if I am going to add binary 1. So here 1 plus 1 क्या होगा?
0 carry 1.
0 carry 1.
0 carry
And
1.
1.
यहाँ पर 0 होगा, carry कहाँ करोगे? To the next number. Okay, carry 1. Clear?
Yes, ma'am.
Yes, ma'am.
Now 1 plus 0, what will be the value?
1.
1.
1. ये 1 है. So 1 को क्या लिखोगे? 1. Then what will be the next value?
0, 0, 0.
0, 0, 0. Then
1.
1. It is my sign bit. Okay. This is my sign bit. I have kept it.
Again.
Yes.
Can you repeat it again?
I will repeat it. I am removing these lines. Again, I will repeat it. Okay. This is my number I have obtained after performing the which operation?
2's complement.
Not 2's complement.
Negation.
Negation operation. Okay, so this is the things I have obtained. So I obtained and I will find out that in the MSB of the new number there is a 1. If it is a 1, then it is which number? A negative number. So negative numbers will be stored in which method?
2's complement.
Complement.
2's complement method. So in the 2's complement, the first step what is? Flip all the zeros to
1.
1.
1 and 1 to
0.
0.
0. So flip करो. ये 0 क्या होगा?
1.
1. 1 will be? This 1 will be 0. This 0 will be?
1.
Now this 1 will be?
Zero, zero.
But don't change the MSB. Okay?
Yes, ma'am.
Don't change the MSB
Yes,
because now it becomes which bit? Sign bit. Okay?
Yes, ma'am.
Next,
yes, ma'am.
what we are going to do? Add which binary one to the
Two's complement.
to टू द रिजल्ट ऑफ द स्टेप वन. इसके रिजल्ट को
Yes, ma'am.
रिजल्ट में हम लोग वन ऐड करेंगे. तो फर्स्ट स्टेप का रिजल्ट क्या है? द रिजल्ट ऑफ द फर्स्ट स्टेप इज दिस वन 0 0 0 1 0 1.
Yes, ma'am.
So here I am going to add a binary one. Okay.
Yes, ma'am.
So when we are going to add 1 plus 1, 1 plus 1 क्या होगा? 0 carry
Carry on one.
0 carry 1 होगा. So ये क्या हो गया? 0.
Yes, ma'am.
We are carrying
Yes,
1 here. ये 1 carry हो गया. Over.
Yes, ma'am.
Now 1 plus 0 will be?
Unable to understand.
Yes.
One,
I'm
one.
unable to understand.
Who is not getting it?
Me.
What's your name?
Ma'am, Kamrup.
कामरूपा. बताओ, तुम बताओ. जिसे समझ में नहीं आ रहा है बताओ. कहां पर तुम्हें नहीं समझ में आया? On which line you, after which line you are not getting?
Ma'am, the last part, that ones and one.
This one?
Yes, ma'am.
This line?
Yes.
Okay. देखो. This is my 5 ना? ये मेरा 5 है ना? I'm going from the very beginning. ये 5 है ना?
Yes, ma'am.
इसको क्या करना है? इसको क्या करना है बताओ? What we are going to do?
Complement.
कॉम्प्लीमेंट निकालना है. कॉम्प्लीमेंट आएगा तो 0 क्या हो जाएगा?
One.
और 1 क्या होगा? 0.
Yes, ma'am.
Okay. So this 1 will be converted to,
Zero.
and 0 will be converted to 1. This much you are clear?
Yes, ma'am.
Now here what you got? 1.
Yes, ma'am.
यहाँ पर क्या आ गया? एमएसपी में 1 आ गया.
Yes, ma'am.
तो ये कौन सा नंबर बन गया?
MSP.
नेगेटिव नंबर.
Okay.
Okay, when you got a 1 in the MSP, it becomes which number?
Negative number.
Negative numbers will be stored in which method?
Two's complement method.
2's complement. So 2's complement का पहला स्टेप क्या है? We need to find out the 1's complement.
Okay, ma'am.
Okay. So ये नंबर को फिर हम लोग क्या करेंगे? फ्लिप करेंगे. 0 को क्या करेंगे? 0 को क्या करेंगे? 1 एंड 1 को क्या करेंगे?
Yes, ma'am.
0. ये साइन बिट को मैं और चेंज नहीं कर रही हूँ.
Okay, ma'am.
साइन बिट जैसा है वैसा ही रहेगा. ओके.
Okay, ma'am.
Next, after I got this one's complement, we are going to add plus. प्लस कितना ऐड करेंगे?
One.
1. यहाँ पर क्या लिखा है?
Add binary one to the result.
बाइनरी 1. ऐड 1 ऐड हुआ. ठीक है.
Yes, ma'am.
So 1 plus 1, when we are adding binary 1 plus 1, मेरा रिजल्ट क्या आएगा? 0 कैरी
Yes, ma'am.
1. तो यहाँ पर हो गया मेरा 0 कैरी कितना हो गया?
One.
कैरी 1. सो अभी 1 plus 0 कितना आ जाएगा?
One.
1. देन ये 1 क्या है? जैसे है वैसे ही लिखोगे.
Yes, ma'am.
ये 0 जैसे है वैसे ही लिखते जाओगे नीचे नीचे. This 0 as it is you have written here. समझ में आया?
Yes, ma'am.
देन ये मैं बोली हूँ एमएसबी को चेंज नहीं करेंगे, एमएसबी जो 1 है वैसा ही रहेगा. Are you getting? I will not change the MSB.
Yes, ma'am.
अब बताओ कितना नंबर आ रहा है वहां और नहीं जाएंगे. वो एमएसबी है, वो 1 है, उसे वैसे ही रखेंगे. सो व्हाट इज द वैल्यू नाउ? 2 to the power
6.
2 plus 2 to the power 1. What is the answer?
6.
6. और ये 1 इंडिकेट क्या करेगा?
-6.
-6. Do the compiler giving you -6?
Yes, ma'am.
Are you clear now?
Yes, ma'am.
Can you repeat it again for the
Ma'am,
last
Clear?
time?
if the number is not negative, then we will not use 2's complement.
No. If the number is not negative, then 2's complement is not needed.
Okay.
Okay, ma'am.
Okay. I will give you one question. You try it.
Okay, ma'am.
You try it. Again, we are going to discuss it. Now, let my value is 9 here. Okay. Note down the question. All of you note down the question. Okay.
Ma'am, -11.
-11. All of you got the result -11? Just a minute. Just a minute. So we will do this from
No, ma'am, it's fine.
okay. Just 2 minutes. Okay, I will not take your much time. Just 2 minutes. So what is the value of 9?
1001.
Okay. Now flip it.
01111.
Okay. All of you got this value?
Yes, ma'am.
Yes, ma'am.
Then put 2's complement.
Yes.
Sorry, 2's complement. Then add a binary 1 to it. Then 1 plus 1 is
0
0.
1
Carry 1.
minus 1010 0 0.
All of you got this answer?
Yes, ma'am.
Yes, ma'am.
So 2 to the power 3 plus 2 to the power 1. 8 plus 2. What is the answer?
Minus 10.
Very good.
Yes, ma'am.
So tomorrow we have our lab.
Yes, ma'am.
Okay, again I will just discuss that cycle part. We have stopped it in the mean. Okay, and we are going to start with the assignment 2. Okay.
Okay, ma'am.
Thank you all.
Thank you, ma'am.
Thank you, ma'am.
Ma'am, ma'am,
Thank you,
one
ma'am.